Hi guys, welcome to my channel. Today I will going to teach you how to make a data science project on Belarus Car Price Prediction. As we can see, we have the data of that country's cars, which will have the different type of like its brand, number. Wait a second, let me take it to top. Like its make, model, price, year, condition, mileage, fuel type, volume, centimeter, colors of it, transmission, drive unit, and segments as is data dictionary. Then we have go to our we have created in the basic format as of writing it EDS part of it, like analysis images of here, like right here you can see there are so many. Okay, and then the one notebook which is right now I have using the EDA, then it's Python scripts part. For it I have installed a virtual environment. Right here you can see here how I have established, and for establishing the main part of every these part 6 codes, I have developed a structure manner, like it will going to take the data sets from the data file as car CSV as the first part, then it will preprocess, take the preprocess one from the data preprocessing one and preprocess it, and returns right here preprocess part after it. Then it will going to remove the outliers, and then it will going to represent it like here. Then it will going to save it. Then we will going to take the heat map of whole situation. Okay, then we have the then we will going to take the EDA part. Okay, and then we will going to go for the model parts, like it we will split it in the XY test, range test split part, and then train the models. Okay, right here I have only used the dictionary tree part. If you have interested in another part you can do it. Right now I have going to teach you how to continue it in the advanced format. Okay, so let's go to our first part, as we will going to do the pre-processing of it. Right here let's review the code. We have taken the pandas and scale in pre-processing import label encoder part. Then we have define an function pre-process data. It will going to handle the normal feature of pre-processing part, like it will going to eliminate the unnecessary columns, like we have taken the df as the main store, drop columns is equal to model and segment in place true as it was not needed, and drops the, then we have dropped the rows of missing values right by writing this command. Then for eliminating the too much amount of companies, we have developed the country style part, right? Like we have taken the luxury European, mainstream European, Russian or Eastern European companies, then Asians, then Americans, specialties, and other types. Like, like from the data set, I have taken as the luxury Europe part of the data sets, every companies right here. like Land Rover, Jaguar, Aston Martin, BMW, Chrysler, Audi, MG, or etc. Then mainstream Europe, Roland, Citroen, Seat, Citroen, Skoda, Mini, and Smart, or any other type of, and mainstream as. Then we have taken the Russian or Eastern European parts of companies like Proton, Jack, Iran, Odo, Rodu, Reliance, or rest of the companies that we have taken. And then we have taken the Asian companies like Torreda, Nesa, Asia, Cherry, Honda, or Suzuki, or any other type of company in the Asian parts, like you can see right here by scrolling it. Okay, this then we have taken the 11 Americans companies right here which were present in the data sets. Okay, then we have taken the 11 for specialty ones, and then the return its other part of if any other type of come in. Then we have taken the make segment. To make segment, apply car make. Then we drop the make column as it was never no needed in the analysis part. Then we have defined columns to encode, like it will going to take the column as conditions, fuel type, transmission, color, drive unit, make segments, label encoding part, as it will going to take the columns of call. Then def bracket call is equal to lel fit transformation, and return def. Right here you can see, as I have tell you, it will going to take the main data set from the, then it will going to pre-process it, then it will going to transfer the pre-processed data to the before outlier remover, and right here so the pre-processing complete as saved as this. Okay, at the end of when I will going to execute it through main part, I will going to let you know how it was done. Okay, then we have taken the, then we will going to go to our outlier part. Okay, then we have defined the function as remove outliers score def calls threshold 3. It will going to remove the specific amount of which columns. Okay, z nev apps stats z score def df bracket columns. It will going to now creating a clean data of it, z score less than threshold and all dot all axis 1, then return df. Then we have go to our remover part. We have taken the iqr method for a specific column, in which we will going to take the df column as contain 0.25, then df column 0.75. In HQR method we will going to minus the Q3 minus 1 Q1, then we will sorry, then df column less than or equal to d1 minus 1.5 into IQR, then end or this, and it will going to return its data. Then it will going to load the, right here we have for defining the part of it, we have taken the data, the process which we have taken, and then this. Okay, then this we have removed the df price tag part using, then we have saved the clean data. Okay, and it will going to end and show its first 5 columns. Okay, then in EDA part, this is also an EDA part in which we have taken the pandas module, cborn and matplot, and we will going to take its plot figure size 10,6 and full heat map of it as df.con bracket anode true is equal to cmap coolworm, and plot title as correlation matrix heat map. Okay, and it will going to read the data from it. Okay, so then we will going to go to our EDA part. In this part I have already done the EDF before this video, so that it will going to get easy and easy to understand for you all guys. Okay, so what, first of all we have taken the modules which are necessary for it, as import pandas as pandas, then numpy, cborn and matplot, and take the set side style as white grid. Okay, of cborn. Then we have taken the raw data, then we have taken the load the preprocess one, then clean data after outline remover and display the clean data. Right here you can see as it has the 0, 1, 2, 3, 4 and price in US dollars as 5, then 50 million, and this figure and its year of manufacture, condition as 2, second year, second, and mileage covered, then fuel types, then volume, color of that, transmission and drive unit and make segments. Okay, then we have started the main part of EDA. Then plot figure as figure size 12 by 6, compute values by it as make count is equal to df cleaned make segment value counts reset index, like here it will going to. Okay, then we have taken the bar plot with q method for color mapping. We have taken the cborn bar plot x equal to make segment, y is equal to count, data will is equal to make count, order make count, make segment, u make segment, relative build is for various amount of colors, like you can see right here, like it has blue, purple, I don't know what colors they are called right now. Okay, so then we have replaced the numerical values with car numbers, sorry, numerical name Okay, x is equal to range, len, make counts, labels, make counts, make segment, rotation 90, and we have defined the title as distribution of car make segment, and is car x is car make segment and its counts. Okay, then we have taken this graph right here, you can see. Okay, then here we can see the in the graph we have the 0 as American counts, then Russian as 1, then mainstream as 2, luxury as 3, and others as 4, and 5 as specialty, and Russian, sorry, Asians are very minimum right here. The car segment formats. Segments. In the datasets, most of the cars, like right here, you can see the Europeans are winning, luxury winning, Europe, whole Europe parts. Like right here, you can see the luxury, majority of the luxuries, then mainstream, then Russian, Eastern European. However, the dataset also have as American and Asians, then some specialties such as Tesla and different type of them. Okay, then we have taken the category wise variable distribution. For this we have taken the subplot method, 2 comma 3 figure 20 by 10, and then we have taken the count plot of first as condition color data preprocessed, and ax equal to ax equal 0, and this. Then at ax part will going to define the reasoning of it, like right here, condition, this and this and this. Okay, then for the fuel type we have defined this, like color wise it is different, then transmission, and then similarly color, and we have taken the text params as x is equal to x rotation 90, and as a counter plot and drive unit hue, and then the similar way and counter plot of make segment also, and then we have given the tight layout of it, then we have show the. Okay, so let's see how this graph is showing the conditions. Okay, like first of all let's see the graph. Okay, then we will going to check the car condition. Majority of the cars are sold in working condition, means the category 2 second hand, and type category 2 and like if you can are average, and some are poor, which are represented as 0. Right here this data is representing every most of the cars in good conditions. Okay, then for the most of the cars are running on petrol, right, 1 as the petrol right here, and 0 as diesel. Okay, and this as in the real life we have the petrol as currently primary, then diesel, and right now we in the state of establishing the alternative sources of it, which we have seen the at the least amount. And then we have the transmission type. The dataset shows the manual transmission category as small, more common than the automation, missing part. Okay, as a 0, then this and this. Okay, manual. Okay, then we have the driving unit. First wheel drive as the category 1 is the most dri common driven train, and then rear as rear wheel as 0, then all wheel as 2, then 4 wheel as category 3 much less frequently. Right here, which data it was? Yeah, this one. Like right here, I have tell the front one as the most, then rear one and wheel, rear one and wheel, and then four wheelers right here. Okay, and the most popular colors for the cars are, as from the data we have taken, from the 12,000 to cars and 12 cars. Okay, it will be showing as the most popular color as black, silver, blue, white, gray, or other colors are less frequently found in the data sets. Okay, and then we have taken the make segment parts. Where it is? Yes, right here. Category 3 ones are dominating mostly the market that we have seen. Other segments vary in popularity but significantly less represent, like you can see right here in the data. Like they are dominating 3: category 1, then 2, then 1, and then these ones. Okay, then we have taken the continuous variable distribution of them as histograph of years, price in US dollars, miles covered, and volume centimeter. Okay, the car manufacturers from the most are from 2005. Right here, let's view for the more. Just again, let me see it. Yeah, most cars are formed within that 2000, 1990 and 2025. Then the count of cars increases from 1990 and peaks around 2005 to 2010, then gradually declines after that. Since most cars are manufactured after 1980, only those manufactured after 1980 will be considered in further analysis. Then we have go to our price distribution, like here. Okay, most of the cars are priced below the 20,000 US dollars. Maybe I had forgotten. Maybe it could have been the millions data. I have forgotten about what it was. So okay, verify it from the other resources. Okay, the distribution. So a right skewed pattern, right, with an higher concentration of the 0. Wait a second. Wait a second. 2002. 2002, 1, 2002, 10, not 2000 to 10,000. Yeah, yes, 2000 to 10,000. And at highest at the above 15, uh, less relatively frequent than the mileage we have taken. Then we will go and check how much they have to cover the mileage. Okay. Okay. Majority of the car have a mileage of less than 4 million kilometers. There are some spike in the specific mileage value indicating the possible common mileage points in the datasets. Only few of them have exceed the 1 mile limits. Then we have taken the most common part of it, engine volume range from 1750 centimeter to and 200 centimeter. Then there are some peaks around 1000 and 2000 centimeter square, suggesting these are standard engine size. Few car engines have volumes above 3000. Okay, like here you can see in the data, it has been showing that we have taken similarly as right here the peak is coming, and then that. Okay, very less. Then from the conclusion we can see of that part, most of the car in the dataset are manufactured between 1990 and 2015, price below 20,000 USD with mileage under 4 million, have engine volumes primarily between 1,750 centimeter square, and this and the further classification on that.